This LOS is describe and demonstrate applications of the CAPM, Capital Asset Pricing Model, and the SML, Security Market Line. Portfolios can be evaluated by several CAPM-based measures, such as the Sharpe Ratio, the Treynor Ratio, M-squared, and Jensen's alpha. We'll start with the Sharpe Ratio first. So the Sharpe Ratio is a focus on total risk because we have in the denominator the standard deviation of the portfolio, which is a measurement of risk. So the Sharpe Ratio, return to portfolio minus the risk-free rate, divided by the standard deviation of the portfolio, so that's a return to risk measure. The Treynor Ratio is a very similar formula. The numerator, in fact, is exactly the same, which is the return to the portfolio minus the risk-free rate, but in the denominator we have the beta of the portfolio. Okay? So it says here that the Sharpe Ratio suffers from two limitations. A, it uses total risk as a measure of risk when only systematic risk is priced. Remember, unsystematic risk can be diversified away and not priced. And two, the ratio itself, 0.2 or 0.3, it's not as informative. The Treynor Ratio is a simple extension of the Sharpe Ratio and resolves the Sharpe Ratio's first limitation by substituting beta risk for total risk. The numerator and the denominator must be positive for the Treynor Ratio to give us meaningful results. Moving on to the M-squared, the formula for the M-squared is the return to the portfolio minus the risk-free rate times the standard deviation of the market divided by the standard deviation of the portfolio minus the return to the market minus the risk-free rate. So M2 gives rankings that are identical to those of the Sharpe Ratio. They are easier to interpret, however, because they are in percentage terms. A portfolio that matches the performance of the market will have an M-squared of 0, whereas a portfolio that outperforms the market will have an M-squared that is positive. M-squared was created by Franco Modigliani and his granddaughter Leah, hence the name M-squared. Moving on to the Jensen's alpha, the Jensen's alpha equals the return of the portfolio minus big brackets, the risk-free rate, plus the beta times the portfolio times the return to the market minus the risk-free rate. So over here I'm just showing the Greek symbol for alpha. That's the way that you often see the formula listed in the text, okay? So like the Treynor Ratio, Jensen's alpha is also based on systematic risk because we're using the beta of the portfolio. And a portfolio's beta can be estimated by a linear regression again using the market model. So recall, that would be the returns of the portfolio regressed against the returns for the market. The risk-adjusted return of the portfolio is determined using the beta of the portfolio and the CAPM. So you can see this part of the formula is the same as the CAPM, but instead of an individual security, we're doing it for a portfolio and we're calculating the beta for the portfolio. The difference between the actual portfolio returns and the calculated risk-adjusted return is a measure of the portfolio's performance relative to the market portfolio and is called Jensen's alpha. Jensen's alpha is the maximum amount you should be willing to pay the manager to manage your money. So we'll finish this LOS with 3 practice questions. The first one, last year a portfolio manager earned a return of 12%. The portfolio's beta was 1.5. For the same period, the market return was 7.5% and the average risk-free rate was 2.7%. Jensen's alpha for this portfolio is closest to A, 0.75%, B, 2.1%, or C, 4.5%. So the correct answer is B, 2.1%. And how do we calculate that? The Jensen's alpha is the return to the portfolio, which they gave us is 12%, minus, and this is very the same as the calculation for the CAPM, the risk-free rate, 2.7%, plus the beta times the return to the market minus the risk-free rate. So we had 12% minus that calculation gives us 2.1%. So it's a positive alpha. And again, that's the maximum that you'd be willing to pay the manager for his active portfolio management and achieving some alpha. Second practice question, which of the following performance measures most likely relies on systematic risk as opposed to total risk when calculating risk-adjusted return? A, the M squared, B, the Sharpe ratio, or C, the Treynor ratio? So the correct answer is C, because the Treynor ratio measures the return premium of a portfolio versus the risk-free asset relative to the portfolio's beta. So we can see here in the denominator, in the Treynor ratio, we're using the beta. If we look back to the Sharpe ratio, it's basically the same formula. The numerator is the same, but the denominator had the total risk, not systematic risk, which was the standard deviation of the portfolio. And again, if we look at the M squared, we have, in terms of the risk, we're looking at the standard deviation of the market relative to the standard deviation of the portfolio. Again, standard deviation is the total risk. So only the Treynor ratio is measuring the systematic risk as indicated by the beta in the denominator of the formula. So the third and last practice question for this LOS. A portfolio manager generated a return of 15.5% on a portfolio with a beta of 1.2. If the risk-free rate of return is 2.5% and the market return is 11.8%, Jensen's alpha for the portfolio is closest to A, 1.84%, B, 3.7%, or C, 4.34%. So the correct answer is A. The Jensen's alpha, again, is the return to the portfolio minus the calculation for the CAPM. So we had 15.5% was the portfolio manager's return minus the calculation that we do for the CAPM, the risk-free rate plus the beta times the return to the market minus the risk-free rate. And we had a positive alpha of 0.0184, which is 1.84%. And that's the last slide for this LOS. Thank you.